Okay, this is 8.6, part 1, question 8.6, part 1. The diagram, not to scale, shows a pumped storage power station used for the generation of electrical energy. Water is stored in the tank and is allowed to fall through the pipe to the lake via a turbine. The turbine is connected to an electrical generator. The pumped storage AC system is reversible so that water can be pumped from the lake to the tank. The tank is 50 meters deep and has a uniform area of 5 times 10 to the fourth meters squared. The height from the bottom of the tank to the turbine is 310 meters. The density of the water is 10 to the third kilograms per cubic meter. Okay, unknown. Show that the maximum amount of energy delivered to the turbine by the falling water is about 8 times 10 to the 12th joules. All right, so what I did here was I highlighted all of the givens, and those are in blue, and the unknown is in green. Okay, so in this case, what I have to do is convert the volume into mass by taking 50 times 5 times 10 to the fourth and multiplying it by the density. Then I just plug that into P equals mgh, with g being 10 meters per second squared and h being 310 meters. So let's go ahead and do that. Solve. Okay. The mass is equal to 10 to the third kilograms kilograms per cubic meter. Okay. Times 50 times 50 meters times 5 times 10 to the fourth meters squared. Okay. Sorry, it's kind of sloppy there, but I just want to show you before you calculate it out. I have meters squared here and meter times meters here. That's meters cubed. I have meters to the negative 3 here, so I can cancel out that with that and that. Meters cubed times meters to the negative 3 is cancels out. Okay. So what am I left with? I'm left with kilograms, and that's what I want because mass should be in kilograms. Okay, so you might want to stop the video and do the calculation real quick. My mass in this case is 2.5 times 10 to the 9th kilograms. Okay. Plug it into PE equals mgh. PE equals 2.5 times 2.5 times 10 to the 9th kilograms times 10 meters per second squared. G second squared times 310 meters. Okay. In this case, you can go ahead and stop the video and go ahead and calculate that out. Okay. So in this case here, we have kilograms. Kilograms times meters. Sorry. we have kilograms times meters squared per second squared, because it should be seconds to the negative 2, and that's just meters squared. That's where I went wrong. So what this should say is when you calculate it out, you have to calculate it to one significant figure. Okay, I got 7.6 times 10 to the 12th. I'm going to round that to 8 times 10 to the 12th joules. And a joule is a kilogram meter squared per second squared. Or sorry, kilogram meter cubed per second squared. Because right here we have kilograms times a joule is a kilogram meters squared per second squared. There we go. All right, so this should have just been kilogram meters to the -1. Sorry, it's late right now. All right, and this is the second time I've done this video. All right, so we got the maximum energy that can be produced. The second part of this question, the flow rate of the water in the pipe is 400 meters cubed per second. Calculate the power delivered by the falling water. So what I need to do here is calculate the area of water, the volume of water that's falling through, the total volume of water in the tank. Okay, so V equals 50, actually I'll show you here, height, actually area of the surface times the height. All right, V equals 5 times 10 to the 4th meters squared, okay, times 310 meters. Okay, V is equal to 2.5 times 10 to the 6th meters cubed. Okay, so I have my total volume of H2O that falls out during the day, and if it's 400 cubic meters fall per second, the amount of time, T, is equal to 2.5 times 10 to the 6th meters divided by 400, oh, it's meters cubed times seconds to the -1. Cross out meters here. Go ahead and do the calculation. Stop the video. Okay. Do the calculation. We're going to end up with 6,250 seconds, because seconds actually goes on top. Okay, it's a fraction, and it's seconds to the -1, so fraction and a fraction means that it goes on top. Okay, that's the total time. Now all we do is we take that total energy produced, the 8 times 10 to the 12th joules, and we divide it by the time. 8.0 times 10 to the 12th, and the total time that the water's falling out. Okay, divided by 6,250 seconds. Okay, and should say joules. Okay, and our final answer is going to be joules per second, which is watts. Okay, and that's what it's asking for, the power. And go ahead and you can stop the video, do this calculation real quick, see what you get. And what you should end up with is 1.3 times 10 to the 9th watts. So the power delivered by the system is 1.3 times 10 to the 9th watts. Okay, see you in the next question.